Hello, this is a video about sampling distributions. So, let's say that we have a large group of people who are going to vote either yes or no, and we're sampling a portion of that group. The portion that we're sampling is going to be N, and the probability of them voting yes is going to be P. A sampling distribution tells the probability of each possible value. So for example, if you, let's say that with my example here, I'm choosing a group of 10. Let's list out if I were to list out all the possibilities with me choosing a group of 10, perhaps I choose 10 people who all say no. Perhaps one person says yes and 9 people say no, or 2 people say yes and 8 people say no. I can list out all the possibilities and I can find the probability of each one of those happening. If I were to do that, that is a sample distribution. For sampling distributions, these are the formulas we have. So these are the formulas we have. The mean is just equal to the probability itself. And the standard deviation is the square root of the probability minus, and the standard deviation is the square root of the probability times 1 minus the probability divided by n. All right, so for example, let's say we have an exit poll of 3,889 voters. The probability that a voter votes for Jerry is 53.8%. Let's see if we can figure out whether or not, just from this sample, whether or not we think Jerry is going to win the election. First, we can use the probability and the number of things total to find the mean and the standard deviation. Well, the mean is just equal to the probability itself, so the mean is 0.538, and then the standard deviation I have to plug into the formula, and when I do, I get 0.008 for the standard deviation. Now, I can use this, let's analyze this data. So most of the scores are going to fall within 3 standard deviations of the mean. So here's my mean, 0.538 in the middle, and if I add 3 standard deviations on one side and 3 standard deviations on the other, that's going to be the range of values that I have, right? So 3 times my standard deviation of 0.008 is 0.024. If I add 0.024, I get this value, and if I add it, I get this value, and if I subtract, I get this value. That lets me know that all of the plausible values lie between 51.4% and 52.2%. So, since all of the plausible values are over 50%, I think it's safe to say that Jerry was probably going to win based on the sample that we took.